Good evening, children. Today I'm going to teach you chapter 6 of your textbook that is on light energy. First of all, we will see the speed of light in different media. Speed of light in air or vacuum is 3 into 10 to the power 8 meter per second. Speed of light in water is 2.25 into 10 to the power 8 meter per second. Speed of light in glass is 2 into 10 to the power 8 meter per second. A medium is said to be denser if the speed of light in it decreases. It is said to be rarer if the speed of light in it increases. So from here, we go to refraction of light. What is refraction? The change in the path of light when it passes from one optically transparent medium to another is called refraction of light. Now, these are the experimental observations about refraction. Number 1. When a ray of light travels from a rarer to a denser medium, say from air to water or from air to glass, it bends towards the normal. So here is the incident ray from air to water. You see this ray bends towards the normal. 2. When a ray of light travels from a denser medium to a rarer medium, say from water to air or from glass to air, it bends away from the normal. So in this case, this is water, this is air. A ray of light comes from water to air. So we see this ray bends away. It goes farther away from the normal. 3. When a ray of light falls normally, that means perpendicularly, on the surface separating the two media, it passes on deviated. That is along the same path. So here we have, this is air, this is glass, and here we have air again. This ray falls perpendicularly on the surface separating the two media, and it passes straight. So that is what we mean by saying passes on deviated. Then we go to the terms related with refraction of light. The first term, incident ray. Remember, when we use the word incident as an adjective, its spelling ends with T. Okay, here it describes about this ray. So incident ray. The ray of light falling on the surface separating the two media is called the incident ray. So this is the incident ray because it comes and falls on the surface separating the two media. So this ray is known as incident ray. The next term is refracted ray. The ray of light traveling in the other medium in the changed direction is called the refracted ray. So remember, refracted ray is in the other medium. So this is the refracted ray. And if you look carefully, this is the ray that has changed its direction. So in the changed direction, a ray which is in the other medium in the changed direction is known as refracted ray. The next term is normal. The perpendicular drawn on the surface separating the two media at the point where the incident ray strikes, that is, at the point of incidence, is called the normal. This is the perpendicular drawn to the surface at the point of incidence. So point O here is the point of incidence because this is the point where the incident ray strikes the surface. Okay, so we call it the point of incidence. So a perpendicular drawn on the surface at the point of incidence is known as a normal. Remember children, we do not call all perpendiculars as normal to the surface. Only the one that is drawn on the surface at the point of incidence is called the normal. The next term is the angle of incidence. The angle between the incident ray and the normal is called the angle of incidence, and its symbol is small I. So this is angle of incidence. The next is angle of refraction. The angle between the refracted ray and the normal is known as angle of refraction, and its symbol is small r, not capital R, small r. Okay, so this is the angle of refraction. We go to the laws of refraction. I put star mark here because they are very important laws which we will be using them from class 8 up to class 10. Refraction of light obeys the following two laws, also known as Snell's laws of refraction of light. And just keep in mind children, in ICSE normally these laws are given by the name Snell's laws, not laws of refraction. Alright, so most of the time the question also will come, state Snell's laws. Law number 1. The incident ray, the normal at the point of incidence, and the refracted ray all lie in the same plane. Okay? The incident ray, and remember for a normal usually we call it in full the normal at the point of incidence. So the normal at the point of incidence and the refracted ray all lie in the same plane. How do we explain it? A very simple explanation is like this. When you draw the incident ray, you draw the normal and then the refracted ray on a sheet of paper. They will all be on that same sheet of paper, which we call the plane of paper. So they will all be on that flat plane surface. Okay, so that is what we mean by all lie in the same plane. For the law number 2, for a given pair of media and given color of light, the ratio of the sine of angle of incidence I to the sine of angle of refraction R is a constant, that is sine I by sine R is equal to a constant. Okay, these are the conditions for a given pair of media. That means there should be at least two media here. And then a given color of light. Okay, given color of light. The light color usually will be mentioned. Then we get this ratio, the ratio of the sine of angle of incidence, which is denoted by small I, to the sine of angle of refraction R is a constant. Which means if you take the ratio of sine I by sine R, that is equal to a constant. What do we mean? That means even if you measure different angles of incidence, then you get different angles of refraction. If you take the ratio of these, all right, sine I by sine R of these angles, you will find you will get the same value, which means this ratio is a constant. Now, before I go on, I would like to mention these facts which you have to keep in mind. The first law deals with the rays. We have the incident ray, then we have the refracted ray, and then the normal at the point of incidence. All right, these are in the same plane. So first law deals with the rays along with the normal. All right, but in the second deals with the sign of the angles. When you have to write the word sine in full, please write it as SINE. But if you attach it along with an angle, like what you have here, sine I, sine R, then you can write it in short as SIN. Never write SIN here. This should be SINE. All right? These sine I by sine R are trigonometric ratios which you will be doing more in maths. Okay? So for now, you just have to take sine I by sine R as they are, because this portion will be done in maths. But the ratio, and another fact that you have to keep in mind, remember children, there are not many ratios here, only one ratio, the ratio of the sine of angle of incidence to the sine of angle of refraction. So there is only one word ratio. Ratio of sine I by sine R, okay, is equal to a constant. Now this constant is denoted by a Greek alphabet mu, all right? So this is a Greek alphabet mu, which is its symbol. So for this constant, we denoted it by mu. And this constant mu is known as the refractive index of the second medium with respect to the first medium. Okay? Remember, sine I by sine R is equal to constant mu, and mu is known as the refractive index of the second medium with respect to the first medium. And this ratio, this mu, can also be found by taking it in terms of the speed of light. So if we take it in the speed of light, mu is equal to speed of light in first medium to the speed of light in the second medium. Remember again, it's a ratio. Ratio of the speed of light in first medium to the speed of light in second medium. I hope you are clear. Okay, then we go to effects of refraction. Now, one of the effects that we have is the depth of water in a vessel when seen from air appears to be less. Okay? All right, so here is water. This medium outside will be air. So we have the bottom of the vessel to be here. Let's take one point which we name as point O. From this point O, we will consider only two rays of light which will be coming from it and which will go in different directions. Okay? The ray OA, which is incident at point A, which is on the surface XY of water here, all right? So this one is incident perpendicularly. So we have seen for normal incidents, the ray will pass straight undeviated. So it goes straight as AD without any deviation. And it goes to air as AD. Another incident ray which we will consider is OB. This ray OB is not incident normally, but it makes some angle with the normal. Okay, so here is normal BN. Now, just keep in mind, for this ray, it comes from water and then it goes to air, which means it comes from denser medium, then it goes to rarer medium. So when it comes to this surface, it will bend away from the normal. So if you produce it backwards by a dotted line, it will meet this perpendicular at I. So an observer here at C, when he looks at it, he will see the depth of the vessel here to be appearing at I, which is much less than the real depth. Okay, so an observer here will see the depth O at I. And what is this point? This point is the image of O, the point that we consider at the depth of the vessel. So this is the image. So an observer sees the image of O at I, and this is much less. So AI is known as the apparent depth, and this one is the real depth. Okay, and if you look here, the real depth is much bigger than the apparent depth. The next that we see is a coin in water appears to be raised. Okay, how do we know it? Let's take a beaker. Okay, we'll keep a coin at the bottom of the beaker, and then if you like, you can cover a little part of the bottom with an opaque paper so that you will not be able to see the coin. All right, then remain in the same place, don't change your position. Instead, you ask someone to pour water into the beaker. Then after pouring water in a beaker, the coin now becomes visible. Why is it so? Here is a reason. We will consider just one ray of light that comes from this object, which is in water. That means it's in the denser medium. Now this ray is going to air, which is the rarer medium. So when a ray of light travels from a denser medium to the rarer medium, it bends away from the normal. Okay, so it bends away from the normal. If you drop a normal here, you'll find it goes away from the normal. Then we produce this refracted ray backwards. Then you will find that the image of the coin will now be at this point. And this point where you can see the image now, all right? What you see here is the image. It's not the real coin. But to an observer which remains in the same position where the coin was not visible before, now it will be visible to him. Okay? Why is it so? Because now he will be seeing it because image is formed. So he will be seeing the image of the coin. And this coin is raised. If you look here, from here it is raised to this position. It appears to be raised, okay? So a coin in water appears to be raised. The next is the pencil in water appears to be bent. Right? Let's take a beaker or any container where we can immerse a pencil partly. So this is water. This is the level of water. Then we take a pencil, immerse the pencil partially only, not completely, partially, immerse it inside water. We will consider only this tip, okay? So we'll take 2 rays of light from the tip. Remember here, this tip is inside water. So these rays are coming from the denser medium, and then they go towards the rarer medium. So the incident ray from the tip of the pencil, they will now be incident on the surface of separation coming from denser medium going towards the rarer medium. So what happens? They will bend away from the normal. Then we produce these 2 rays backwards. When you produce them backwards, they will be intersecting at a point or meeting at a point, okay? That point must be the image of this tip, because we are taking these 2 rays from the tip. So that must be the image of the tip. Then you draw the pencil from this portion where it is immersed to the tip. You'll find this pencil now appears to be bent and short. Not simply bent, it appears to be short as well. Why is it so? Because of refraction of light. When you observe it from the rarer medium, you will find that a pencil appears to be bent and short. Then we have another example of this, of the applications of this phenomenon that happens, which we call refraction, okay? That is early sunrise and late sunset. Now, before we go into this, let's remember that we have the atmosphere all around the earth, okay? Up to a height approximately up to 300 kilometer. But the atmosphere of the earth is not having the same layer. It's not just one layer of air. There are different layers of air and with different densities. So when one layer is denser than the other, so it means when the ray of light is coming from any object, it will have to pass through different layers of atmosphere. And these different layers are having different densities. As a result, when the densities are different, it's like going from one medium to another medium to another medium, all right? From rarer medium going to denser medium to denser medium to denser medium, right? And the densest layer of the atmosphere is near the surface of the earth. So as you go a little distance away from the surface of the earth, the layer of the air will become thinner and thinner. So they act as rarer medium. All right. So now the rays from the sun, here is the horizon and the sun is still below the horizon. So the rays of the sun that comes from here will have to suffer successive refractions till they reach the observer's eye. Okay. Similarly, from here, because of this successive refraction, now to an observer, if you draw straight with his level, you will see that the sun is here, not here. Okay, because this is a straight path. So an observer will see the sun over here instead of this real position. Hence, if it is in the morning, the sun is still below the horizon, it is visible to an observer here. Similarly, when the sun goes down in the evening, here is the horizon. The sun has gone down the horizon, but to an observer, the sun appears here. So what happens? We have early sunrise and late sunset, okay? Because of refraction, and not just one refraction here. It's successive refractions. So this ray bends, you see? Okay, but to an observer, it will appear straight. I hope that is clear, children. Okay, then the next one is mirage in the desert. Okay, in the desert, maybe there is one palm tree here. And remember, in the desert also, there are different layers of air. So when we have different layers of air, not just one layer, let's take one ray that comes from this object. It will suffer successive refractions till it reaches the observer's eye. Why? Because these tiny sand, which after being blown by air repeatedly, they act as refracting medium. Okay, so they refract the ray that comes from the object successively. As a result, an observer will not notice here, but it will appear to him that the object is here. So what does it look like? It looks like there is water here, so that you get the image of this palm tree down invertedly. So to an observer, it appears there is a pool of water over here, and he will be fooled by that. Okay, so this is known as the mirage. Okay, as a result, this observer will see it to be coming from here. In fact, this is the image formed by the successive refraction from this palm tree, and there is no water at all. So many times the travelers in the desert, they mistakenly thought that there is a pool of water nearby. Then we go to refraction of light through a rectangular glass block. Here we have a glass block PQRS. Okay, let us consider a ray of light AO to be incident in this direction. Okay, so it comes in this direction. So AO is the incident ray. Then we drop a normal at O. When we drop a normal, we get angle of incidence, because this is incident ray, here is a normal, so we get angle of incidence here. Then here is a normal, here is the refracted ray. Okay, so we get angle of refraction. And remember, children, in this case, if it is not mentioned otherwise, there will be air here. So this is the case when a ray travels from rarer medium, it goes to the denser medium. So it bends towards the normal. So we get the refracted ray OB. Okay, so refracted ray is OB. That's why we get angle of refraction also here. Then this ray again will come an incident on surface RS. Okay, in this case, this ray, when it comes at point B, okay, you drop a normal here. When you drop a normal, then we have this normal at point B, okay? Then this is the case when a ray comes from denser medium, it goes towards the rarer medium. So it bends away from the normal, okay? So at surface RS, the ray bends away from the normal. Then we get an angle of emergence because ray BC is known as emergent ray, right? Okay. There are two interesting facts which become the results or the consequence of refraction of light through a rectangular glass block. Number one, produce this incident ray forward by dotted line till you come to D. What you see? Emergent ray BC is parallel to incident ray, direction of incident ray AD. Do you see that? BC is parallel to AD. Okay? So that is point number one. Incident ray produced forward is parallel to emergent ray. So what does it mean? It means incident ray is parallel to emergent ray. Secondly, angle of incidence I is equal to angle of emergence E. Okay, angle of emergence E. So this is the second fact. Okay, I repeat. Incident ray produced is parallel to emergent ray. Angle of incidence is equal to angle of emergence. All right? Because these two are parallel to each other, we take a perpendicular distance between them. Okay? The perpendicular distance xy here between the incident ray produced and the emergent ray is known as lateral displacement. Okay? Lateral displacement. So what do we get from there? It means that the incident ray simply gets displaced from its original direction. So this is the direction of the incident ray. Had there been no glass, it would have traveled straight like this. But because of refraction through glass, it has shifted its direction to BC. It means this ray simply gets displaced from its original direction. Hence, we give this distance by the name of lateral displacement. Then we go to refraction through a prism. Alright, before we go to refraction through a prism, let's have a look at the shape of the prism. In full, this is a prism. A prism, in fact, looks more like a tent than a triangle. Right? So if you pitch a tent, right, what happens? You have this edge here, then you have one plane here, you have one plane here, then you have the ground, then you have the entrance from here, you have the entrance from here. All right? So we have three rectangular surfaces. We have one surface here, we have the other surface here, then we have another surface here. So three rectangular surfaces. We have two triangular cross sections. We call these cross sections, okay? So we have two, one here, one here. So 1, 2, okay? Hence, when we define a prism is a refractive refracting medium, okay, remember it's a refracting medium made of glass or sometimes a plastic, having bounded by 5 surfaces. 1, 2, 3 at the base, 4, 5. Bounded by 5 surfaces. 3 of them rectangular and 2 triangular. Okay? In a prism, there are certain facts that we need to remember. Okay? This edge where the two rectangular surfaces are meeting each other is known as the refracting edge. Refracting edge. Okay? These two surfaces are called the refracting surfaces. Then these triangles, okay, they are known as cross sections. And the front cross section usually, or the cross section of the prism usually is known as the principal section of the prism. That's why when we draw it by the principal section, so usually we get it as a triangle. This is known as the base, okay? And then this angle at the top vertex, this angle is known as the angle of the prism. The angle of the prism. So these are the facts that we have to keep in mind about a prism. So now let's go. How is refraction taking place in a prism? Let us consider a ray PQ which is incident on surface AB, okay? And when it comes to surface AB at Q, we drop a normal, okay? So as soon as we drop a normal, we will get angle of incidence, all right? And this ray is coming from rarer medium, because there is air here, towards denser medium, which is glass. So it bends towards the normal. It does not go straight, instead it bends towards the normal, right? Making an angle of refraction R with the normal here, all right? So we have angle of refraction here. Then this ray continues inside the prism as QR, and then at R it comes to another surface of the prism, and at R, this is the case when a ray comes from the denser medium, it goes towards the rarer medium, okay? So when it goes towards the rarer medium, it bends away from the normal. Look, it bends away. Here is a normal, it bends away from the normal, okay? So we have incident ray, refracted ray, and emergent ray. We will produce this emergent ray backwards to meet this incident ray direction. So what do we see from here? Had there been no glass, this ray of light would have continued in this direction. But because of the prism here, it suffers refraction here, it suffers refraction here, so 2 refractions are coming. Hence, this ray now has shifted, ray RS has shifted. By how much? If you look here, it forms an angle with the incident ray. That means the deviation of the ray RS forms an angle with the incident ray. So in the case of a prism, we do not simply get lateral displacement like in a glass block. Instead, the refraction in a prism makes an angle of deviation which we denote by delta. This is small delta in Greek. So this delta stands for angle of deviation. All right. So we see that in a prism, if a ray comes from here, this ray also bends. This is the base of the prism. So the ray bends towards the base of the prism. This fact is important when we do refraction through a lens. Okay? Then we go to the next, that is dispersion of white light. What is dispersion? The splitting. Please don't write by any. If you want to substitute, you can use only the word breaking. Otherwise, I would prefer to use the word splitting, okay? The splitting of white light into 7 different colors when light passes through a refracting medium like a prism is known as dispersion of light, okay? White light, when it passes through a refracting medium like a prism, then the white light gets dispersed, all right? It gets split into 7 different colors. So this phenomenon is known as dispersion of light. Then we go to spectrum of colors. The band of 7 colors obtained on a screen. So if you keep a screen here, you will get a band of colors. When white light splits into its constituent colors is known as refraction of spectrum of colors, okay? Is known as spectrum of colors. The band of colors is known as spectrum of colors, whereas the process or the phenomenon is known as dispersion of light. And this is the order how the colors will come. Violet at the bottommost, then we get indigo, then we get blue, then we get the green, then we get the yellow, then we get orange, then we get red. Violet bottommost, red topmost. So if you want to remember it easily, you do it by this. VIBGYOR, VIBGYOR. That is the way how to remember it. Remember, violet does not come on top. We start from the bottom to the top. Okay? And this is the spectrum of colors. Thank you, children.